This is my review of the article Tablet-Based Cross-Curricular Maths versus Traditional Maths Classrooms Practice for Higher Order Learning by Monica Volk, Mara Cotič, Matej Zajc, and Andrea Istenic Starcic. This article was about a study completed comparing grade 3 students in Slovenia from 12 different schools who were standardized based on pre-tests into 6 classes as control and 6 as an experimental group. The study aimed to discover if there were benefits to tablet use over other technologies, as well as benefits of using cross-curricular interconnected themes, as opposed to teaching subjects or topics in isolation in maths and then learning later in social studies and again in languages. Before looking at the results, some of the definition used were taken from Kratwall's revised Bloom's taxonomy: factual knowledge, conceptual knowledge, procedural, and metacognitive. I found it interesting that procedural knowledge in these definitions was a higher level than conceptual, where most of my reading has those two flipped. The study was interested in the final level of problem solving, requiring discrimination as well as the use of the two other levels, which were deemed higher level thinking. Other studies on tech had focused on benefits and drawbacks of a variety of technologies, including calculators, graphing calculators, computers, and tablets. Some of these studies had a positive correlation between the technology used and the performance in math, but the researchers in this article wanted to go further to determine if tablets were better in comparison with other forms of technology, and if using the apps that integrated math with other subjects simultaneously would improve higher level thinking skills specifically. The choice of a tablet affected a number of modalities of learning, and this was something I had not necessarily thought deeply about. A tablet, like a computer, has all the virtual representations of manipulatives that allow for cognitive development, but with the tablet, the students were able to be more mobile. They were able to collaborate easily with their peers, they could engage socially and work either independently or together on the tasks on the screen simultaneously, affecting all of the learning domains. During the experiment, both groups learned the same math concepts of telling time, both digital and analog clocks, the same social studies idea about how time passes and timelines, and they learned the language vocabulary for the months of the year, days of the week, seasons of the year. In the control group, math was taught in September, socials in December, languages was in the springtime. The experimental group, on the other hand, started using a calendar, and students were relating their date of birth to different time phases, how many days until the end of the week, how many to the end of the month, and so on. So the language was integrated at the same time as the passing of time. From using the calendar, they then progressed to using an app that they were able to manipulate the hands of an analog clock and figure out passing of time, how many minutes have gone past, and going further to find the symbolic representation as well as the visual representation using the hands on the clock. The second topic that was compared as part of the experiment was orientation. In this, we were talking about grids, coordinates, locating items on the map, moving on to graphing and finding locations, pinpointing locations of objects and creating their own maps. After 7 months, there was a post-test completed on both of the groups. There was a slight increase in performance in the conceptual knowledge, but both of the higher levels of procedural and in particular problem solving, there was a moderate statistical difference. The learning was better. I think probably in relation to the affective domain. Students who were using the connected ideas were problem solving initially to figure out how apps worked, as well as problem solving and using those higher level thinking skills about each of the tasks that they completed. Because technology was involved, they were more engaged. Because they were using something that was light and portable, they were able to interact more with their peers. Another important aspect was the self-pacing that was present on the tablets. So students who were advanced were not being held back. Students who were struggling with concept were able to spend more time mastering that before they moved on to the next item. My personal observations, just to briefly summarize, I chose this article because it's something I had not considered, the actual physical styling of the technologies and how that would impact how the students were able to interact with each other and the classroom. I enjoyed seeing the perseverance in my own classroom when we do activities that are involving the computer. The students definitely get more engaged. They definitely spend more time than they would on a question on a piece of paper. Many of them like the challenge and the competitive nature of some of the tasks. Cross-curricular is not the easiest thing in math, but I have attempted some experiments in this direction with cooking classes and surface area using a designing architecture project with kids making gingerbread houses. One of the things that struck me with this is that for students, technology is just the norm. For me, math without a pencil and paper is really challenging. For them, with their constant use of screens and technology, it's probably the reverse. For them, working on a computer is probably more easy. That was my observations in relation to this article. Interesting to see that the cross-curricular really embedded the math ideas and made it much easier for the students to learn.